Today we are going to discuss the composite function part 2. Remind you once again, the learning outcome for this chapter is state the domain and range of a function and find composite function. The function f and g are defined by f same as x mapping to square root 16 minus x squared. The domain x belongs to real number and x is greater than and equal to -4 and less than and equal to 4. The other function g same as x mapping to square root 5 minus x belong to real number and the x less than or equal to 5. Both function f and g are radical function. The problem is find the composite function g of f and f of g and state their domain and range. The previous solution, we have to solve or to find the range of the function f and the function g. As we know, for the square root function defined, the expression inside the radical signs should be greater than or equal to 0. The expression 16 minus x squared must be greater than or equal to 0. From the condition, to fulfill the function f defined, we can obtain the domain of the function f. So from the given information, the domain for the function f is x greater than or equal to -4 and less than or equal to 4. We substitute x equal to -4, we get y equal to 0. And when x equal to 4, y also equal to 0. So we continue substitution to do the substitution. When x equal to 0, your y equal to 4. From the point, we can sketch the graph to obtain a semicircle. From the graph sketching, we can determine the range of f, function f. So the range of the function f equal to the set y same as y greater than or equal to 0 and less than or equal to 4. We do the same process as function f to get the or to determine the domain and range of the function g. So we let the expression 5 minus x greater than or equal to 0. So we can determine the domain of the function g, that is x belong to a real number and x less than or equal to 5. Function g same as x mapping to square root 5 minus x. So from the function given, we can obtain the x-intercept and y-intercept. So when x equal to 5, we get y equal to 0. And x equal to 0, we get y equal to sub 5 or square root 5. From the graph sketching, we can find the range of function g equal to set y, same as y greater and equal to 0. The following step, we have to determine the existence of composite functions f of g. From the information we obtained at the previous step solution, that is, range of function g is equal to set y same as y greater than equal to 0, and domain of function f equal to set x same as x greater than equal to -4 and less than equal to 4. From the information we obtain, we can clearly show that range of G is not the subset of domain of function f. So, composite function f of G does not exist. So, we must restrict the domain of f of G to those values that are in the domain of f, also in the domain of G, mean that the domain of the composite function f of G must equal to the domain of the function G, or in the other word, mean the object of the composite function f of G must be the subset to the object of the function G. Domain of the composite function f of G must be equal to the domain of inside bracket function G, or the object of composite function f of G must be the subset of object of function G. The next step solution is to find the composite function f of G. So, f of g of x equal to f inside bracket g of x. The function g of x equal to square root 5 minus x. Now, the function g of x become the object of function f. So we substitute the x equal to square root 5 minus x. Now the composite function become square root 16 minus bracket square root 5 minus x square. So after do the simplify, we get square root 11 minus x. Therefore, the composite function f of g same as x mapping to square root 11 minus x. X belong to real number and the x greater than equal to -11, because the expression 11 minus x must be greater than equal to 0. From here, we get the domain for your composite function f of g is x greater than equal to negative 11. Now we are going to restrict the domain so that the domain for the composite function f of g is the subset of the domain of function g. So the domain of composite function f of g is the domain for the function g that is s less than equal to 5 intersect the domain of the composite function f of g that is s greater than equal to negative 11. So finally we have the domain of composite function f of g equal to set of x same as x greater than equal to negative 11 and less than equal to 5. From the domain we obtain, we can determine the range of the composite function f of g. The range of the composite function f of g same as set y, same as y greater than equal to 0 and less than equal to 4.